Japan's summer traditions, Suzuka 8 Hours Endurance Road Race. At this circuit, a demonstration experiment for a project was underway. This apparatus is called the Power Assist Suit. When its sensors detect hand and foot movement, the motor kicks into gear to help with the task at hand. In other words, this suit will help, for example, lighten the load when lifting heavy objects. At the circuit, the pit crew had a go at their usual task wearing this suit. That is, fueling. To refuel motorcycles, the crew has to get ready by vertically lifting these tanks known as rockets. When you include the fuel, the tank weighs more than 30 kilograms. It's quite grueling work.
持ち上げる時が特に軽かったです。で、支えている時も肘ついてるような感じで固定できるんで、普通に持つよりは軽い。
The Power Assist suit was developed by a Japanese venture company, and this type of suit may become available in 2 years' time.
What was especially difficult was making it as light and compact as possible.
What helped realize the lightweight and compact size is the X-GaN, the next generation power device developed by Panasonic. It's actually an 8mm square transistor. Bringing about a power electronics revolution, this small device has the potential to make this happen. X-GaN was born in Kyoto. In Panasonic's Development Center for Semiconductors, as well as various other devices such as LEDs and sensors. Semiconductors are essential to power electronics. At the moment, silicon is the main material used to manufacture them. But with silicon, it is becoming increasingly difficult to meet the growing market demand.
The market wants power devices that are more energy efficient. Another desired feature is compact size. But silicon has reached its physical limit, so it's difficult to further improve efficiency.
The next generation semiconductor material that has been gathering increasing attention is GaN. It is a chemical compound made of gallium, atomic number 31, and nitrogen. GaN is also being used in making blue LEDs, which received the Nobel Prize. When this material is used as a power conductor, it exhibits revolutionary performance.
This is the evaluation board for GaN switching characteristics. It measures how fast the device can switch to high voltages.
This is the time GaN needs to conduct 400 volts, only about 2 nanoseconds or 2 billionth of a second. And this is the result for silicon. As you can see, it takes much more time. When you compare the two, GaN is 10 times faster than silicon. This switching speed is actually what makes miniaturization of peripheral devices possible. Say we wanted to transfer the same amount of liquid in the same amount of time. Because silicon is slower, we would need a larger container. But with the faster GaN, we would only need a small container. The size of the container, which means in this case the size of the peripheral devices. This is why GaN can contribute to miniaturization of products. And it can also help save energy. When electricity is passed through a GaN and silicon transistor under the same conditions, and we use thermosensors to observe the rise in temperature. 3 minutes later. The GaN on the left is green, while silicon turned orange. Electricity is being released and lost as heat energy.
The temperature difference was around 15 degrees. When there is such a stark difference with just one device, then the energy savings for the entire equipment would be quite significant.
There are high expectations for GaN as the next generation power device that can realize high efficiency in smaller size. We hope it will become an epoch-making device in the future.
Research into GaN as a power device began back in 2004. Since joining Panasonic, Yasuhiro Uemoto has been involved in the development of semiconductors. When he came across GaN, he remembers being super excited at its latent potential.
It opened up a whole new world. The features it offered were a double-digit difference, so